Welcome everyone. Welcome to NS Institute. Today we learn about the fuel cell. This is an important topic of the chapter battery in your syllabus. So first we'll go through the definition of the fuel cell. What is a fuel cell? So as we have already learned in the batteries, that the primary batteries, like in the primary or secondary batteries, uh, the principle is like the electrochemical cell, right? So basically the fuel cell is also an electrochemical cell like whatever is present in all other batteries, and it will convert the chemical potential energy contained in readily available fuel oxidant system into electrical energy. Means that it will directly convert the chemical potential energy into electrical energy by applying these fuel oxidant, okay, or by supplying this fuel oxidant. So basically the fuel cell is like an electrochemical cell, whatever we have already learned as the basic principle of a battery, which converts the chemical potential energy into electrical energy by supplying or by giving this fuel oxidant continuously. So basically the principle of the fuel cell is same as that of electrochemical cell, but there is some kind of differences between this fuel cell and all other cells. So the main difference or the only difference is that these fuel and oxidant, whatever we are using or whatever we are supplying or giving, are actually stored outside the cell. It is not, or it cannot be stored inside the cell. These are actually stored outside the cell, and these fuel and oxidants are or will have to be supplied continuously and separately to the electrodes at which they undergo redox reactions. Now as long as you will supply the fuel and oxidant to the system, so then the redox reaction will be happen, and then electricity will be generated along with heat. Now as long as you will give this fuel and oxidant, or as long as you will supply this fuel and oxidant, the redox reaction will go on and the electricity will be generated. So therefore these fuel cells are actually dependent on the supply of fuel and oxidant. If you will stop the supply of this fuel, the redox reaction will be stopped and electricity cannot be generated. So fuel cells are capable of supplying current as long as the reactants are given or reactants are being supplied. As long as the reactants will be supplied, the fuel cells will be operated. When you will stop the supply, the fuel cell cannot be operated because the redox reaction cannot go further, and therefore the electricity cannot be generated. So basically what will be the overall reaction of this fuel cell? So the overall reaction will be like fuel plus oxidant, whatever we are just mentioning, that fuel plus oxidant will be the reactants. The products will be like the oxidized or the oxidation products along with electricity, and heat will be generated. So basically there can be several examples of fuel cell like hydrogen oxygen fuel cell, propane oxygen fuel cell, and the CH2 oxygen fuel cell. So now on next we'll try to learn the first one, that is the hydrogen oxygen fuel cell. Now whenever we are just going through different kind of examples of these fuel cell, the most important one or the most successful fuel cell will be hydrogen oxygen fuel cell. Now these cells consist of two inert porous electrodes made of graphite impregnated with finely divided platinum, nickel or palladium silver alloy, and the electrolyte solution will be used of KOH. So basically here this KOH solution, you can say that 2.5% KOH solution will be used as an electrolyte. So the fuel cell consists three main parts or three main segments. That is, first one will be the anode, second one will be the cathode, and third one will be the electrolyte or electrolytic solution. So here the electrolytic solution will be KOH solution of 2.5% KOH. Now what is happening at the anode? At anode basically the oxidation reaction takes place. what will happen in the cathode? In cathode, the reduction reaction will take place. So what is basically happening in these hydrogen oxygen fuel cell? In this cell at anode, this hydrogen will be oxidized to water by releasing electrons. Now these electrons will flow from this anode to cathode, and those electrons will be accepted by oxygen, and therefore the oxygen will be reduced to OH minus. So basically at anode, this hydrogen is being converted, or it is actually oxidized to water by releasing electrons. Releasing electrons means these 4 electrons, releasing 4 electrons. Now these oxygen will take these 4 electrons or accept these 4 electrons, and therefore the oxygen will be reduced to OH minus. So what will be the overall reaction? The overall reaction will be like hydrogen and oxygen, these are the reactants. Those will react with each other to produce water, heat and electricity. So this is the overall working principle of hydrogen oxygen fuel cell. Now these fuel cells work like batteries, but they do not run down or need recharging. Why? Because as long as you will provide this fuel or the oxidant, these fuel cell will be operative, because the redox reaction will go on and the electricity will be generated. So therefore they produce electricity and heat as long as the fuel is supplied. When you will stop the supply, of this fuel and oxidant, the working of this fuel cell will be stopped, because the redox reaction will be stopped. If the redox reaction will be stopped, then the products like heat, electricity cannot be generated. So they produce electricity and heat as long as you will supply the fuel. Here the fuel is hydrogen and oxygen. So a fuel cell consists of anode and cathode sandwiched around an electrolyte. Here the electrolyte will be KOH solution, and a fuel such as H2 here means in this hydrogen oxygen fuel cell, the fuel is like H2 we are using, and it is fed to the anode, and the air, basically air consists of this oxygen, it is fed to cathode. In a hydrogen fuel cell, a catalyst at the anode separates hydrogen molecules into protons and electrons, which take different paths to cathode. Now the electrons go through an external circuit, creating a flow of electricity. The protons migrate through the electrolyte to the cathode, where they unite with oxygen and the electrons to produce water and heat. So this is the overall working principle of hydrogen oxygen fuel cell. Now we have already learned the working principle. Now if these kind of fuel cells or these kind of cells are connected in a series, it will be transformed in a fuel cell battery. This is the working principle of fuel cell, whatever we have learned. If these fuel cells are connected in a series, it can be converted into a fuel cell battery. Now in production of this electricity, or the products of this kind of fuel cell will be heat, electricity, and along with the oxidized products, right? So basically in this case the byproducts will be heat, water, and in some cases there will be carbon dioxide, which is actually environment friendly. They are not any kind of harmful chemicals, so basically they are environment friendly. So in the production of this electricity by this method, the byproducts are heat, carbon dioxide, water, which will not cause any kind of pollution of the environment. Basically they are environment friendly. So now what are the major applications of this fuel cell? These fuel cells can be used in a wide range of applications, including transportation, material handling, stationary, portable, and emergency power backup applications. Now they can be used as auxiliary energy source in space vehicles, submarines and other military vehicles. And the second point, this one is very important, that the product water produced is a valuable source of fresh water for astronauts. Like the product of this fuel cell, or the main product, sorry, the byproduct of the fuel cell is actually water, along with heat, and the main thing is that the electricity. But the byproduct water, whatever is produced in this fuel cell, is actually a valuable source of fresh water for astronauts. And fuel cell, third point, that is the fuel cell is preferred in spacecraft because of its lightness, because because of its light weight. As it is having a very less weight, it is very much preferred in the spacecraft, because in the spacecraft you cannot carry some kind of things which is having more weight. So therefore it is very much preferred in the spacecraft because it's having very light weight. So now we will go to the PEM. PEM means that proton exchange cell. So this is basically a hydrogen oxygen fuel cell. So in this PEM, the fuel is like hydrogen oxygen gas, and the products, what will be the products? The products will be like water, heat and electricity. So those are the reactants, that is hydrogen and oxygen are the reactants, and the products will be water, heat and electricity. Now what is the importance of this PEM? So PEM is basically the hydrogen oxygen fuel cell, but here in this proton exchange fuel cell, what is happening is that hydrogen gas and oxygen gas is being used here as a fuel, and the products of this reaction in the cell will be water, heat and electricity. Now this is a big improvement over internal combustion engines, coal burning power plants and nuclear power plants. Why? Because all of which will produce harmful byproducts. But here in these PEM or proton exchange cell, no other harmful byproducts or not a single harmful byproduct will be produced. So therefore this is environment friendly. This is environment friendly because in all other cells, like whatever I have mentioned, that is internal combustion engines, or you can say that coal burning power plants, nuclear power plants, in all these cases different kind of harmful byproducts will be produced. But in this PEM or proton exchange cell, whatever the products or the byproducts we are getting, like water and heat, and in some cases carbon dioxide will be generated, but it will not cause that kind of pollution. So basically these are environment friendly. So this is a big improvement, or you can say this is a big achievement also. So what are these advantages of this fuel cell? So basically these fuel cells can operate at higher efficiencies than combustion engines and can convert the chemical energy in the fuel cell to electrical energy with efficiency of up to 60-70%. And fuel cells have low emissions than combustion engines. These hydrogen fuel cells emit only water. The hydrogen fuel cells will not emit any kind of carbon dioxide. So therefore there is no question of air pollution that creates smog and cause health problems at point of operation. Also these fuel cells are quiet. It will not create any kind of noise during operation as they have fewer moving parts. So these fuel cells having comparatively high efficiency, that is nearly 70%, or you can say that 60-70%, while other sources have efficiency like 15-20% in gasoline engine and 30-35% in diesel engine. The efficiency of the fuel cell does not depend on the size of the power plant. It doesn't depend. The efficiency of the fuel cell doesn't depend on the size of the power plant. Now this maintenance cost is very low. If it will only bear the installation cost, but the maintenance cost will be very low. As long as you will supply the fuel, the redox reaction will happen. It will electricity, and the electricity will be generated continuously. Now, fuel cells are more efficient in producing the mechanical power to drive the vehicles and require less energy consumption. And most important, whatever I have mentioned, that these fuel cells have low emissions than combustion engines, and these hydrogen fuel cells will not emit any kind of carbon dioxide, so therefore there is no there is no CO2 emission, and therefore no air pollutants is generated to create smoke, or you can say that there cannot be any kind of health related problems at point of operation. Also, these fuel cells are very much quiet. It will not create any kind of noise, as they have very fewer or very less moving parts. The moving parts are very less, so therefore when you will operate the fuel cells, it will not create any kind of noise. It can be very quiet. It will be very peaceful in nature. So along with these advantages, there can be some disadvantages also. I have already mentioned that this maintenance cost is very low, but initial cost of the fuel cell is very high. Initial cost means the installation cost of this fuel cell will be very high, but after the installation, the maintenance cost is very low. So there is some kind of advantages, as well as there can be some kind of disadvantages also. Now, this lifetime of the fuel cell is not known accurately, as it is not rechargeable. So therefore the lifetime of the fuel cell is not known properly. As long as you will provide the fuel and oxygen, the fuel cell will be active in nature. It will generate electricity by running the redox reactions, but the lifetime of the fuel cell is complete. It is still unknown. Now, there is a problem of durability and storage of large amount of hydrogen. So these are some kind of main disadvantages of running the fuel cell or operating the fuel cell. So now we will go through some kind of important differences of primary, secondary, and fuel cells. Now, in case of primary fuel cell, it only acts as galvanic or voltaic cell, that is, it will only produce electricity. So it is having just one time usage. There is a chemical energy will be converted into electrical energy. But in case of secondary cell, it acts as galvanic or voltaic cell while discharging, means that producing electricity when this chemical energy is being converted to electrical energy. And it can also act as an electrolytic cell when it will consume electricity, that is, electricity is being provided for the reversible reaction, that is the this electrical energy will be converted into the chemical energy. Now, this fuel cell, in case of fuel cell, it is a simple galvanic or voltaic cell, that is that it will only produce electricity. Why? Because this is not rechargeable. As long as you will supply the fuel or supply the oxygen, it will be active in nature. The redox reaction will go, and the electricity will be generated. So it is a simple galvanic or voltaic cell because it will only produce electricity. Now, here in case of primary cell reaction is not reversible, as I have already mentioned. It is having one time of usage. When this chemical energy will be converted into this electrical energy, you have to discard the cell. Now, in case of secondary cell, the cell reaction is reversible. It is reversible reaction. Here also in the fuel cell, the cell reaction is reversible in nature. The primary cell, in the primary cell, it cannot be recharged. It is having one time usage. When the chemical energy will be converted into electrical energy completely, the cell has to be discarded. Now, in case of secondary energy, it can be recharged, means that chemical energy can be converted into electrical energy, that is the discharging process. After that, you can provide the electricity from outside to just make the reaction reversible in nature, or to make the backward reaction. Now, here in case of fuel cell, energy can be withdrawn continuously. Why? Because as long as you will provide, as long as you will supply the fuel and oxygen, the redox reaction will go on and electricity will be generated. So therefore, energy cannot be withdrawn continuously in case of fuel cell. Now, the primary cell can be used as long as the active materials are present. When it will be finished, the active materials will be finished, it will stop running, or it cannot be used again. It is having only one time usage. Now in case of secondary cell, it can be used again and again by recharging. When it will be discharged again, you can put the electricity for the reversible reaction, then the energy will be stored and again you can use that. Now in case of fuel cell, the reactants should be used, or reactants should be provided continuously. As long as you will provide the reactants, as long as you will provide the fuel and oxidant, it will act continuously. The redox reaction will go on, and therefore the electricity will be generated continuously. But one thing I should mention, that it does not store energy. As long as you will supply the fuel, it will generate energy, or the energy will be generated, but it cannot store the energy. Okay, so examples of primary cell can be like dry cell or primary lithium cell. Examples of secondary cell can be like nickel cadmium battery, secondary lithium ion cell. And as I have already mentioned, that examples of fuel cells will be like hydrogen oxygen fuel cell, CH2OH O2 fuel cell, like this one. So basically these primary cells can be used in pacemakers, watches, transistors, radios, etc. So mostly that is a one-time usage, where these after these means as long as these active materials are present, this can be used. When the active materials will be finished, it has to be discarded. Now in this case, in the second these uses of secondary cells can be like electronic equipments, automobile equipments, like whatever we are using in our laptops, or you can say in the mobile phones, in the smartphones, like in the digital cameras, laptops, flashlights, etc. And uses of these fuel cells, we have already mentioned that it is having great use in space vehicles due to its lightweight, and the product of these fuel cells, or the byproduct of the fuel cell, that is a water, is a source of fresh water for astronauts. So these are the basic differences between these primary, secondary and fuel cells. So thank you for watching this video, and I will provide the study material link of these class in the description box. And if you have any doubt regarding this class, you can write in the comment section. I will try to sort that out. And once again, thank you for watching this video. If you like this video, please share this video as much as possible, and please subscribe our channel. So see you in the next class. Bye bye.